Okay, so this is the fourth and final part of a series I'm doing called Thailand is a Titan Elephant, and this is going to be quite a bit long. I try and get into a bit more into the science behind it, so try to convince people more that this is just not some illusion or imagination. There's actually science behind it. So as I mentioned earlier, or in the other video about Linnaeus in the Hindu cosmology or Sanskrit myth, another name it goes by is Akupara or Chakwa, and it's not only in Hindu Sanskrit, it's in lots of different cultures around the world. And the cosmology is a turtle supported by 4 elephants in the north, east, south, and west. And you can find lots of this on the internet. I'm not going to go into detail. I want to get into the science because Hinduism is quite deep. You need to really study it at an early age and become a scholar in it to understand it all. What I'm just trying to do is just get the gist and the general idea about Hinduism. And it's just something to base a foundation on into the science. And so what I think Thailand is the Viroopaaksha, the elephant of the east. And you can read about the legend of Linnaeus or the Great Turtle. And what it talks about is the sons of Sagara. They actually go to look for the white horse, and on the way for looking for the white horse, they come across the 4 elephants, and they dig up the earth looking for the horse, and they find the elephants, and they actually find the horse too. And the name of the horse in the legend is Achai Shavas, is a 7-headed flying horse, and this horse actually goes back to the story about Garuda. And this is the pictures of the sons digging up the earth, looking for the horse and finding the elephants. There's some more pictures of Hindu mythology. And there's actually a temple in India, it's called Viroopaaksha, which is located in Hampi. And this is the temple with all the amazing fractals in architecture. And perhaps some of the sandstone used or in the area is also perhaps Titan elephant. Pretty amazing place, amazing architecture, and it's also the temple with all the erotic statues. Yeah, there's kind of weird stuff going on here. Yeah, and that's quite weird as well. Yeah. So what really got me onto this? I saw pictures coming up on the internet about Titans. I thought, yeah, they're a bit far out in their imagination. And what really clicked is when I saw Tyson's mud fossil video in the US on a beach in Oregon, and I thought I've seen this before somewhere. And then I realized that these kind of bumps, formations, are very, very similar to what we get in Thailand at the place called Puin Rong Klang National Park. So these are on the beach. So I took these from Tyson's video. Big thanks to him, and took some photographs of the video. Okay. And what I'm going to take you to is Puin Long Khai, which is kind of central north in Thailand. It's quite far from my home. It's about a 7-hour drive. Okay, so this is a picture from satellite. And now we're going to move in, and okay, so people see this, yeah, it's just a bunch of rocks, yeah, and yeah, I would think exactly the same a few years back, but it's when you get on the ground and look in the detail that it really kind of blows your mind. So yeah, it looks similar to elephant skin, but I wouldn't say it was without more evidence. Okay, pachyderms, very thick skin. A little bit closer. Closer again. It's quite similar. Okay, and this is a place called Lan Hin Teak. Those gaps go quite deep, probably about 2 or 3 meters down. Okay. But where it gets really interesting is the bumps. Okay. So this is what the bumps look like, and this looks like this is elephant skin under the microscope. So it's very, very identical in some ways. Okay. And then why elephants have these bumps? If you look that they're in a hot environment and they protect themselves with dust. So maybe these bumps are kind of a way that the dirt sticks to the skin, perhaps. And I found a very good research paper on the internet by a guy in Africa. He actually does a dissertation on elephant pachyderm skin. So that's where I got a lot of my information from and just did the comparisons. So he's got elephant skin under the microscope, and I'm just comparing this to the rock formations. So you can freeze the text, freeze the video and read the text. I'm not going to read it for you, but this puts more science behind what I'm trying to get people to understand. And someone is actually, by the looks of it, cut a slice off here, and you get this kind of bloody effect. Okay, that would actually look like a cell, part of a skin cell. Okay. So what I question on is the rock morphing biology, or were these creatures living, breathing, actual life forms? So I don't know for sure, but it could be either way. I really don't know. But what I'm saying is that the stone, the rocks, they are morphed in the same way as biology is. Okay, so geology is biology because it's morphed in the same way. Were they actually living, breathing creatures? I don't know for sure. They could be. So I'm not saying either way yet. It's very hard to prove. Okay, so I'm going to show you some pictures. So this is Pui in Long Kra in Thailand, and this is a picture of Tyson's beach in Oregon. Okay, so it's very similar. Maybe not the same creatures, maybe different creatures. And if you look at this pattern, elephant skin under the microscope, and this, it's identical. Okay, so this is not kind of sort of water comes through here and erodes the rock in this shape. That doesn't happen. That's not possible. Okay, and what they're trying to say is a rock noodle field. They're saying it's sandstone eroded. Okay. Or what they also say is sometimes they say it's volcanic activity, but volcanoes don't make these kind of shapes with their lava. Okay, that would be impossible. Okay. Okay, here's a picture of some guys doing some abseiling down the rock face. I wonder if they actually realized that they were actually tying their abseiling ropes around a elephant skin cell. Hilarious, yeah. Okay, so there's some science behind it. Okay, so if we look down here, this is the stratum spinosum, and the upper layer is the dead cells, the keratin. So when these cells die, they get pushed up and they become dead cells, and they fall off gradually. And this picture here from the internet and these two pictures here are pretty much identical. Okay. And if we look at the terminology used in skin and geology, they use the same vocabulary. Now, why is that? If you imagine a geologist in a class of biology or a biologist in a class of geology, they would think, what's going on here? Why are we using the same words for everything? Yeah? So it's geomorphology or geomorphology. And if we look here, there's another part of the layer. So these are the keratin dead skin, and then here is called the squam flake off surface. So these pictures up here and these pictures, real pictures here, they're identical. Okay, it's exactly the same. So why would lava or erosion form exactly the same shapes? It wouldn't. It's just not possible. So either something's morphing, biology, or it was an actual living creature, which would have been absolutely huge, billions of times the size of today. Okay, so I walked around it. This stuff is really, really difficult to walk on it. You almost twist your ankle everywhere you go. Yeah. Okay, it's a beautiful view. And these kind of holes, these are where sort of nerve endings, strands, blood cells, all this kind of stuff would go in and out of the tissue. And if you live in Thailand, you ever got a chance to go to Phuyin Longklang, I definitely recommend it. It's an amazing place, and the air is just fresh, amazing. Lots of pine trees, flowers, birds. It's a great place, yeah. Okay, so exactly the same thing happening again. And as I said in the video, micro to macro, if this is a small cat and this is a giant cat, they're both still cats. It's logic. Okay. And if you look at this picture here, so this is dead keratin cells making their way before they peel off. And what they're saying here is sun cracks. Yeah. I don't think sun cracks will kind of make this shape. If you look at dried mud, it doesn't make these kind of shapes. So, well, when I actually first went to this place years and years ago, they actually said it was fossilized shells, yeah. So actually the signage has actually changed over the years. So these geologists, they're making up stuff. They don't really know what they're talking about, yeah. And this is other places around the world, okay, not just in Thailand, what I'm showing you. And this is what I think is a leopard skin cell located in South America. It would be a different species, but it's kind of similar. Okay. And this is an amazing place in Tasmania. So these are, they call it tessellated pavements, but this is cells. This is DNA, or the stratum cornea and keratin. Yeah? Erosion and pressure don't make these kind of cracks. And if we look at the skin cell structure under the microscope and what we see on the ground, it's identical. So in the gaps would be iron. Okay. Look at that, almost straight lines there. Okay, so let's look at what the geologists say. Is sandstone considered igneous rock? No, sandstone is not igneous rock, but mechanically formed sediment rock of arenaceous group. And igneous rock is made of a cooling of magma inside the earth and lava on the surface, so from cooling magma. Sandstone is mostly composed of sandstone grade particles that has been consolidated together in forms of beds and basins of sediment. Quartz is the dominant mineral in sandstone. What I actually think is actually, if it's got silica in it, it was life form. So when you crack open rocks and look inside the rocks, if it's got that glistening, that's a kind of silica. That means it was some kind of fatty tissue or life form. And it says sandstone is a classic sedimentary rock composed mainly of sandstone. Feldspathic sandstones are derived from granitic type, primarily crystalline. So crystalline rocks, just got a message, if the sandstone is dominant plagioclase, then it is igneous in origin. So sandstone plagious is igneous, and then it says it's not igneous, so kind of confusing. Yeah? Okay, so as I'm saying, primary crystalline, so silica. If it's silica, it was life form, I think. Okay, so this is geologists give an excuse. It's lava, it's lava, it's lava. Oh, that was lava formation. But this is what lava does. It's all messed up, gooey stuff. It doesn't form these kind of shapes. Okay, or lava bombs, or it's just all messed up, gooey stuff. Sandstone is not like this. Okay, there's no structure to this. Okay, yucky. Oh, that's a place at Pui Long Kai. Actually, after I took this photo, I looked at it, it says do not touch. Yeah. Okay, this is one of the bumps on its own. I call this one the Merkel cell. Yeah? Angela Merkel. Yeah, I wonder where that name came from. Okay, so yeah, this would be like strands of nerve endings, blood cells, all going through these kind of areas. I'm not actually sure what part of anatomy this would be here. It's all quite confusing. Okay, but yes, nerve endings, strands, blood vessels, all that kind of stuff will be going in and out of here. And what's interesting is the pinky rock, so pink sandstone, is kind of fleshy. And if you look at an elephant, actually elephants, after they've been clean and a good scrub and all that dust come off, they're actually very, very pink and fleshy. You see this here? So that would kind of make sense. And what I also think is that even though the life form is not actually dead, I think the rocks still grow. They're like crystals. Once they get water on them, they keep expanding. Yeah? So the rocks are kind of alive. They're still growing. Yeah? They're getting bigger and bigger and bigger. And also have these kind of cell structures. Yeah? Okay. This is very near to the other place. So what they use in Khmer temples or in India, the pink sandstone, and look at this pinky kind of flesh. Okay, so it kind of looks cellular in structure, you know. This is interesting because this is Pui in Long Kra, where I think it's elephant skin, and this is the 3 whales very far away in Thailand in the northeast, and very, very similar. Okay, this one's a bit more square, this is a bit rounder. Okay, so that's interesting. I probably need to make another video, but I don't think these are whales. It's part of something else that is much, much, much bigger. Okay. See, look how long that goes back, and at the back of here is all smaller pieces of this, long strands in different shapes. There's only these 2 or perhaps 3 that actually look like whales. The rest of it doesn't. And this is going back to the dissertation I was looking at. Some guy in Africa doing a master's or a PhD on elephant skin. So you can freeze this and read this in your own time. Okay. Cornea strapon African elephant. and there are the pictures that are pretty much the same, yeah. Okay. So geology is clearly dermatology and histology with the same technological language. Dermatology, skin, and histology is a study of microanatomy of cells, tissues, and organs as seen through a microscope. So what we're looking at is lipid layers, membranes. The skin barrier function is provided by the dead skin keratin stratum, corneum. The lipids under the SC are stratum spinosum, epidermis, columnar cell stratum, stratum granular, and stratum and dermis collagen, composed of 3 lipid classes: samarides, cholesterol, and fatty acids. Okay, so all this stuff in dermatology and the rock formations are identical. Okay. And another interesting, look at the size of this. These are cells, and all the other rocks are kind of broken away over time. And if you look at this, what's supporting it are the integral membrane proteins, and on top are the peripheral membranes. And over time, they still bond together and stick together like a glove. And I find it really interesting. Yeah? So the rest of it's worn away over time, but some of the cells actually still join together. So look at the comparison again. Integral membrane protein cells at the bottom, and then the peripheral membrane proteins on the top. So they bind to surfaces of integral proteins. That's why they fit perfectly, and the rocks haven't fallen off after all these, God knows how many years, millions or billions, I don't know. And we see this in lots of places, yeah. This is, I think this is in the US somewhere, and this is the one in Myanmar, yeah. So some people think they got this rock from the sea and carried it up and put it up on another rock, and it just balanced there perfectly. It's hard to believe, but all the other cells broke away, and these 2 cells stayed together, yeah. It is truly mind-boggling. Okay, some other pictures. So yeah, I love this statement. Yeah, go back. Small or big, they are still cats. It's logic. Macro to micro, it's the same. Okay, so it's just logic. You can't really argue against it. Yeah. Okay, some more pictures of cell structure and rocks. Okay, glycoprotein, peripheral protein, integral proteins. Okay, Merkel cell. So the big spread out desquamating corneocyte. Okay, it's exactly what we see on the ground. Basal membrane, basal rock, elephant skin under the microscope. This is what I also found. I found this on Gochang Island. Yeah. So these hair shafts, the hairs have gone, worn away over the years, but the shafts still remain. Looking at Tyson's video in Oregon, he's actually found hair shaft with hairs, cuticles still attached. Okay, it's pretty amazing. Another thing I was looking at on my trip, I stopped off here on the way, and I kind of think that this kind of mountain ridge along here is actually a main artery where blood actually used to flow through here.
Make a video
and
then again.
zoom it in closer. So the blood vessel has collapsed over a period of time. And what you find in the riverbeds and all around are these kind of like round, bulgy rocks, and they look like blood pellets. And okay, it looks pretty huge, but as I said before, the rock, they're still growing, they're still expanding. They haven't finished growing. The mountains are still growing. Everything's still expanding. Yeah? And it's all kind of interesting, the topography to look at this. It's hard to figure out what you're actually looking at. Okay. And this could have been mined years ago. That's why it's all got these ledges. Some of it are, I think, giant trees, and some of this is ancient mining. Yeah? And what I also noticed when you're driving around is that a lot of the mountains are very similarly shaped like elephants also, like baby elephants. So this is at the foot of the bigger mountain, and this looks like some kind of spine. So this actually looks like a baby elephant growing to be a bigger elephant. So mummy elephant is the whole huge mountain in front of this one, and then this is at the foot of this mountain. And these shapes, yeah, they look like elephant foreheads everywhere you go. So it's not only 3D that we're seeing this kind of fractal universe biology, it's also in 2D. See, that could be 2 foreheads of elephants. Yeah? And then this is another mountain also. Yeah. So are mountains geomorphing biology in some way? Okay. And looking around the world at Google, apparently there's 4 elephants, but there's lots of smaller elephants also. And I found this in Halifax in Canada, and that kind of looks like the shape of an elephant. And this rock formation also looks like skin. And when I look at the geology map of Thailand, where you find Permian rock, you find this kind of texture of elephant skin. So that the pattern kind of matches. Okay, so all the way down here in the red. And this is another interesting place. This place I go to is called Got Si Chang, which actually means elephant color island, because the rocks are very similar to the color of elephant skin. And I can't give a very clear picture from satellite, but this is the same kind of rock texture in Phu Hin Long Klan. Also have caves, and you find a lot of this reddish stuff which looks like blood. That's quite ironic, yeah. So there's 2 islands in Thailand which are called Elephant Island, and both have this kind of Permian rock. This is all cracked up. This is kind of like bone. This is interesting. This is like a cell, a sebaceous cell, which is actually a sweat cell gland, and that is where the sweat comes through this tiny hole here. Perhaps this is a sebaceous gland here. Okay. After I made my first video, someone pointed to me to Mike Wilkerson's video, which is amazing, unveiling a Titan, which he's found this mountain in Spain, and his work is pretty good. He goes into detail, very detailed, good video, very interesting. I learned a lot from it, and he goes into the biology and the organs. And if you have a chance, you should watch this as well, worth watching. I think it's 3 or 4 parts, but he's really done his homework and he's done an excellent job on that. And I learned a lot about plasma, the bones, and the best part about it is when this French documentary team, they go inside the ear of the elephant and the video in detail, yeah. And this is in Thailand, and this is also what Mike found in Spain, the trabecular bone, and the rock looks exactly like both. So he found this in Spain, and I found this in Thailand. These kind of rock formations are actually bone, trabecular bone, yeah, all broken up. Okay, you can read a bit more about Permian rock. And what's kind of even weirder is that you find a lot of these similar rock formations downsizing. So they don't have to be absolutely huge mountain ranges. They could be small mountains. So this is another place in Phang in the south of Thailand. It's called Phung Chang Cave. And obviously it's a temple there, and the people that named it that obviously thought it is an elephant too. Okay, and this is they've made a statue of a broken elephant. Okay, and if we look at the outside of it, yeah, it kind of looks like an elephant. Here, there's the trunk going down. Here is the shoulders, the hind legs. Okay, yeah, but when you get inside, it's really interesting. Yeah. So everything is kind of calcified in stalagmites, stalactites, which is which. Okay, so this is just like all the guts and intestines and everything is just spewed out underground, yeah. And macro to micro fractal, we even see a little tiny shaped elephant inside the wall of the cave, yeah. Okay, so this is just like inside the intestines, the stomach, and stuff is still spewing out over the, I can't say millennium, don't know how many years, yeah. This is a bit of a pareidolia, imagination. I don't think that is, looks a little bit like an elephant, yeah. Don't think it is. But we see this around the world, yeah. Okay. When I first started seeing this, I thought it's just people's wild imaginations, yeah. But when you look on the ground, look at the cell structure, they have a valid point. It's not some crazy idea, yeah. This is Canada again. Okay, it's a little elephant in Oak Island. And to really understand it, we have to look at the Hindus and the way they built stuff. They understood what was going on. Macro to micro fractal. Upsizing, downsizing, and well, they've got all these heads and arms. I think it's also to do something with the mind and the brain, and it's kind of coded into a story. So eventually when I understand it better, I would try and do a video about the fractal side of things. Okay, this is done by a Thai artist, yeah. And Thailand is kind of shaped like an elephant, looks like an elephant on the ground. Elephants are very, very special. The Erawan elephant is on so many temples around Thailand. Okay. So, yeah. Thailand has an elephant on the flag, shaped like an elephant. And yes, strangely enough, perhaps Thailand, or more than perhaps, I think Thailand is actually an elephant too. Okay, so that's about it. Thank you for listening. I hope you found it interesting. Maybe one day you might find some kind of creature somewhere. Okay, so thanks a lot. Bye bye.